All right, ladies and gentlemen, welcome to video number 6 for Redox and Electrochem. This is going to be our first video where we're going to start to get into electrochemistry. And you're going to need your notes open to page 23. This video is really just going to be me presenting some vocabulary words. And in terms of putting the vocabulary words together and giving them a context, that's mostly stuff we're going to be doing in class. So these are the words I'm going to be using, and then we're going to be practicing a lot in class with a lot of these ideas. So introductory definitions for electrochemistry. First of all, what is electrochemistry? Right? Let's start there. Electrochemistry is a branch of chemistry or processes that use redox reactions. So that's why they're tied together, because we have to have a redox reaction that converts between chemical energy and electrical energy. So it's basically taking the chemical energy that from bonds, from having atoms bonded to one another, and it converts that or turns that into electricity. Because electrochemistry, right? It kind of sounds like electricity, and it's all based on electrons. Where is electrochemistry seen? Where is it used, or is it found? Batteries, cars. If you think about the battery of a car, the whole reason that your car can start is because of the battery in it, and that battery is actually using a redox reaction. The battery in your cell phone, I mean, the entire reason that we have portable electronic devices is because we've managed to create portable batteries that can generate electricity simply from a chemical reaction that's taking place inside the battery. If you've heard of like lithium batteries, right? It's lithium from the periodic table, and it involves a redox reaction with lithium. And the whole reason this works, the basis of electricity is the flow of electrons. Well, in redox reactions, what is the subatomic particle that's being transferred? It's electrons, right? So it's like we have these redox reactions that are moving electrons around. Electrochemistry is simply harnessing that and saying, hey, let's see if we can get these electrons to move, and then you use that movement of electrons to like do stuff, to power our cell phone. Reminder, and this is a massive reminder, in order to have something that conducts electricity, there are two requirements. You need to have something that has a charge. So in this unit, that's the electron, and the charge has to be able to move, to flow. So if the charge isn't moving, it can't conduct electricity. But if the charge can move, then it can conduct electricity. And so what we see with electrochemistry, and not just a redox reaction, is that, all right, we have these redox reactions where we know we have electrons that are being transferred from our reactants from one to the other in the redox process. An electrochemical cell is something that takes that idea and it literally separates out your oxidation from your reduction, and it forces the electrons to move externally. And by forcing those electrons to actually travel from the place where they're lost, oxidation, to the place where they're gained, reduction, now we have electricity that we can use to do things like, check Snapchat. So an electrochemical cell is simply a device that sort of uses this idea of a redox reaction to put the electron movement to good use. And these electrochemical cells are going to be either spontaneous or non-spontaneous. So just a little refresher, spontaneous means that the process happens on its own without any outside intervention. It just goes. Once you set it up, it just boom, it happens, and you don't have to do anything to it. Or non-spontaneous, which means that you have to force it to happen. It won't happen on its own. So we're going to be talking about these two types of cells, the spontaneous type and the non-spontaneous type. We're mostly going to focus on the spontaneous type. A voltaic cell. This is the spontaneous type. That is what it is called. An electrochemical cell that spontaneously, so we do really want to associate those words with one another, that spontaneously turns chemical energy into electrical energy, i.e. Electricity. And batteries are all examples of voltaic cells because they happen on their own, and they just a battery will simply, you plug it in, you plug your battery into something, you put it into a device, and now suddenly the device works, and it has electricity that it can use to do things. So a battery contains a voltaic cell. Again, we want to have this direction though. We understand that we're turning chemical energy into electricity. It's this, let's take the redox reaction and generate electricity from it, rather than the other way around, which is going to be our non-spontaneous ones. So last thing is just some vocabulary associated with all electrochemical cells. So these are not specific to voltaic cells, but we're going to start with voltaic cells. So anode, cathode, and salt bridge. Words that we use when we're talking about batteries, when we're talking about voltaic cells. Anode, what is the anode? It's the site in the electrochemical cell, which basically means that it's just a place, a location, where oxidation occurs. So oxidation happens at the anode. So anode, we want to associate oxidation. These two words, they go together. Cathode. What is the cathode? It's the site in an electrochemical cell. So again, it's a place, it's a location. It's the place where reduction occurs. So we have these two words, right? Anode is where oxidation occurs. Cathode is where reduction occurs. And in class, I'm going to give you a mnemonic for helping to remember that. But those words go together. So cathode is always going to be reduction. Anode is always going to be oxidation. And then the last term that we really use, especially in voltaic cells, is something called a salt bridge. Because charges are moving around a lot in a voltaic cell or in an electrochemical cell, we have to maintain what's called charge balance. Otherwise, the cell will eventually, quote, go dead. If you've had a battery go dead, there's some reasons for that. So a salt bridge, it maintains charge balance. It helps to keep the charges evened out in an electrochemical cell. So we're going to be seeing pictures and diagrams of voltaic cells in class, but this gives you a leg up on the vocabulary that we're going to use to talk about those cells.